Hi guys, so I'm just going to review our electricity unit that we started last week. I'm just going to go over a few of the main vocabulary words that I want to make sure that we cover. The first one is static electricity, and that occurs when there is an imbalance of positive and negative charges. Imbalance means that they are not balanced, so you either have more negative or you have more positive charges. If you look here at the picture, this is an example of static electricity. This person rubbed its hair against a balloon and it caused static electricity. So that means that there is not electricity flowing because there's way more negative or way more positive charges. They're not equal. The next word is current electricity. That's when electrons flow through a circuit. Items are connected to a power source. So for this example, I said that I wanted you to think of my hair straightener that I use in the morning. When I plug it into a wall or into the outlet in the wall, it then has electricity. So that means that I'm able to turn my straightener on then. And inside that cord that is connected to the wall, to my actual straightener, there is current electricity running through it. Because from that outlet, it's giving that source power to let that electricity flow in a nice current through that cord. Having to do with that, conductors are a material that allows electricity to easily flow through it. So with my hair straightener, you have your cord that you plug into the wall, and then you're able to turn on your straightener. And I want you to think of that cord, and you're able to touch that cord because it is surrounded by an insulator. But inside that insulator, that rubber material, is that cord inside that the electricity is running through. So a conductor is a material that allows electricity to easily flow through it. So that cord inside is usually copper, like you see here on the penny, that's flowing inside that rubber insulator that's letting that electricity flow through it. With an insulator, a material that blocks the flow of electricity through it, that insulator insulates that conductor so that you don't get zapped or shocked from that cord. It kind of insulates it, it protects it. And examples of insulators are paper, rubber, plastic, and glass. So on that straightener cord that I was using, it is outlined with that rubber plastic. Okay. A series circuit and parallel circuit are different. When you think of series, I want you to think of just one. So in this series circuit here, electricity is flowing in just one path. So it's connected to that battery. That battery then lights a light bulb. Then that cord's going to flow to the next light bulb and back to the battery. It only has one path. So if this light bulb here were to go out, to burn out, that one would burn out as well because it's on the same exact cord. What's different with a parallel circuit is that there's more than one cord. So in this circuit, electricity flows in two or more paths or loops. So here's a path here that goes to the light bulb, and then it goes to the next light bulb. However, here is another cord that goes to the light bulbs as well. So if there's a break in the loop, say right here or down here, the other bulb is still going to be lit because there's another pathway for that electricity to flow through. So when you think of series circuit, I want you to think of one path, where parallel, I want you to think of two paths.